Today we'll be starting part 2 of the work on quadratics. So last chapter we were looking at quadratic expressions. What we're now moving on to are looking at solving quadratic equations and also what happens when we go and try to draw these on a number plane. So just to start off with, we're looking at quadratic equations. So before we were looking at expressions. So an expression is just a bunch of algebraic terms put together into some, you could say, meaningful way. When we're looking at a quadratic equation, we're looking at finding an unknown value so that the left and the right hand sides of an equal sign are equal to each other. So in our first sentence, a quadratic equation can be written in the form ax squared plus bx plus c equals to 0. So you would have seen we did write this out like this a couple of times in our earlier work with expressions, but now we've got an equals part and we're making it equal to 0. And one really important thing is that a cannot equal to 0. So if a was equal to 0, then we don't have an x squared term, then that's just linear, okay? It's no longer quadratic. So that's why that's really important. And this format here, if we write an equation like this, it's called the standard form. So how we go about changing an equation into standard form is we just want to put all of the terms on the one side and we've just got equals on the other side. Usually by convention, we try to keep x squared positive if possible, but sometimes a question could start with a negative in front of the x squared, and that's perfectly fine to work with too. So what we're looking at in these first ones is we're changing these equations to standard form. Okay, so we want them to look like this. Basically, we want to move everything onto the same side of the equal sign, and because I've already got x squared on the left, I'm going to move the 2x over by minusing it, and then I'm also going to move the 7 over also by subtracting it. So then we'll have x squared minus 2x minus 7 equals to 0. So that's basically what standard form is. When we come to the next question, the first thing that you need to do is expand that bracket. Okay, get rid of that bracket by expanding. So that's x squared plus 4x equals to negative 2. So also we don't want to have any brackets, so that's our first step. Now we can take that negative 2 and we can add that over. So then your answer is x squared plus 4x plus 2 equals to 0. And so we've changed that equation into standard form. All right, now when we're looking at a quadratic equation, so these things here, it's different to what we did with linear equations. So linear was when x, you could only have one x. Okay, you couldn't have squares or cubes over it or any other powers. So it's just numbers with single x's, okay, and then it had equals something or other. Okay, so linear equations, you can get one solution out of a linear equation. When we're looking at a quadratic equation, there's actually different numbers of solutions depending on what the numbers are. So we could have two solutions of a quadratic. So there could be two numbers that will make the equation work. There could be one solution, so it might just be the one value that's going to work, no other values work. Or it's also even possible to have no solutions. So it could be that when you write out your equation, there's no possible number that you can substitute in to make that work. What we're going to look at more in this chapter, in this year, is two solutions and one solutions. We'll do more of that when we go to approach Year 10 work. All right, there's a special rule that we use when we're going about solving equations, and it's called the Null Factor Law. Okay, so what I want you to think about is if I know that two numbers multiply to give 0, what sort of possible values can you have for those two particular numbers? So if they multiply to equal to 0, what's special about the pair of numbers that we need to work with? Now, if you have to think about it, if we need to multiply to give 0, the only way we can get 0 out of some numbers is if we multiply by 0. So what that means is either of those two numbers will need to be 0. Okay, so 1 or both numbers needs to equal 0. Okay, so that's going to be a really important what do you call it? Function? Yeah, that's going to be really important. Anyway, so that's basically what the null factor law means. So either one or both of those numbers need to be 0 if they multiply to give 0. So when we go about solving quadratic, this is why all that work with factorizing was important. What we need to do is, firstly, we're going to convert the equation into standard form, and then we're going to factorize wherever we can. And then part 2 is because when we factorized it, we're going to have double brackets, which means we've got something times something else equals to 0. And you can see now where the null factor law comes in. If these two things equals to 0, then one of them must equal to 0. So then part 2 is to solve each bracket to equal to 0. So either the first one is equal to 0 or the second one is equal to 0. And then that will give you your possible solutions. So let's have a look at these two questions here. These ones I've already factorized for you. So we know that we've got x times this bracket x minus 5, and that's equal to 0. Okay, so if these two numbers multiply to give 0, either x is equal to 0 or x minus 5 is equal to 0. And those are actually our possible solutions. So we can write x equals 0 or x minus 5 equals to 0. And when we solve for x in the second equation, x is equal to 5. So then we've got our two solutions. So therefore, we can say x equals to 0 or it's also equal to 5. So both of those answers will give us a correct solution. When we come to the next question, we've got two lots of brackets, okay? So either the first bracket is equal to 0 or the second bracket is equal to 0. So we can write that as x plus 1 equals 0 or 2x minus 3 equals 0. And then we can go about solving that. So the first one, x plus 1 is 0, then x is equal to negative 1. And then if I've got 2x minus 3 equals 0, I move the 3 over by adding it, and then I divide by 2. So then x is also 3 over 2. So those are two possible answers for x that will make this statement true.